Hello, today we're going to be looking at number 15 of the 2013 Aime I. So the problem goes like this, and is the number of ordered triples A, B, C of an integer that satisfies the conditions. First, A, B, and C, they are between 0 and 99, and there exist integers A, B, C, and prime P, where this is true, and C, P divides these three. And lastly, each order triple ABC and BAC, they form arithmetic sequences. Okay, so first of all, what we're gonna do is take advantage of this last kind of piece of information, right? And so we can rewrite big A, big B, capital C as B minus X, B and B plus X, right? Because they form arithmetic sequences, so that's what we can do. And the same thing for small b's, and same thing for the lower cases, B, A, C. We can make that into A minus Y, A and A plus Y, right? And then we know that P divides these three, and so let's try to rewrite A minus A, B minus B, and C minus C based on these things, right? And so that's gonna make A minus A is going to be, so this is going to be, let's say, B minus X minus A, right? So that's B minus X minus A, and then B minus B is going to be just B minus B is A minus Y, right? So minus A minus Y. This is equal to B minus A plus Y, and then C minus C, that's just going to be B plus X minus A plus Y, right? So B plus X minus A plus Y, which is equal to B plus X minus A minus Y. And so what we're going to do next is we're going to add these two together, right? So if we add these two together, then we get 2B, and then these two cancel, and then these two come together, right? And so we get minus 2A, and then minus Y, right? And then next we're going to multiply this by 2. This gives us 2B minus 2A plus 2Y, right? Oh, these two look similar, right? And so if we move these two over here, also keep in mind that all three of these are multiples of P, right? Multiples of P. And since this is a subtraction of the multiples of P, and this is a multiplication of the multiples of P, that means these are still multiples of P, right? These are still multiples of P, and of course we want to subtract these two, right? And if we subtract the bottom one from the upper one, we get, what do we get? 3y, right? And so since we subtracted multiples of P, 3y is a multiple of P, right? But then remember that we did say that C is less than P, and C is A plus Y. That means A plus Y is less than P, right? And so that means Y is less than P, so this cannot be P, right? That means P must be equal to 3. And that is one big thing that we can gain from here. P is equal to 3. Let's put that in yellow. Okay, so we have P equals 3. And if P equals 3, rewriting this, we get that 0, and then B, A, C, and then 3. That means that these three can only be 0, 1, 2. And so now that we know B is 0, A is 1, and C is 2, we can just substitute these values into the A's, B's, and C's over here, right? This is going to be B minus X minus 1. This is just going to be B because B is equal to 0. And the C minus C is just going to be C is B plus X. So it's B plus X minus 2. Okay. And so now we know that these three are all multiples of P, right? And then multiples of P, that means multiples of 3 because we saw that P is equal to 3. And so they are multiples of 3. So this gives us that, first of all, B is a multiple of 3. Multiple of 3, right? And since this is a multiple of 3 and this is a multiple of 3, that means minus X minus 1, that must also be a multiple of 3, right? So since minus X minus 1 is multiple of 3, then if we multiply minus 1 to both of these, then this is still going to be multiple of 3, right? And so that means that x must be congruent to 2 mod 3, right? And so we have these two important truths here. B is a multiple of 3 and X is 2 mod 3. Let's do this in yellow. B is a multiple of 3 and X is 2 mod 3. So with this information, all that's left for us to do is to just see what n is, right? How many triples are there? And so if we do that, if x is equal to 2, right? And then now this clause gets important. A, B, and C is between 0 and 99, right? So keep that clause in mind. So if x equals 2, what can b be? Since these three must all be 0 or greater, 0 or positive, and b must be a multiple of 3, then the lowest that b can be is 3, right? And then since their maximum is 99, then their maximum is 9. Yeah, since then the maximum will be 96, because 96 plus 2 has to be less than or equal to 99, because that's c, right? And so b is 3 to 96, right? And this is how many values? This is 96 minus 3 divided by 3 plus 1, that's 32. So that's 32 values, right? And then next one, if x is equal to 5, right? So the reason we jumped from 2 to 5 is because x is 2 mod 3, and so the next x value is 5. And so this gives us b is equal to 6 to 93. Because 6 minus 5, that has to be greater than or equal to 0, and 93 plus 5 has to be less than or equal to 99. And so what you can see here is every time we subtract 3, we add 3, and we subtract 3, right? Okay, so that just means that every time we go down once, like the numbers at the ends of the possibilities of b, they get cut off, right? So for the first one, we had b equals 3, 6, 9, all the way up to 90, 93, 96, 96, like that, right? So this was 32 values. But then for the next one, just these two aren't possible, right? So it's like we take out 2 every time. We take out this one and this one, we take out 2 every time. That means that the total number is going to be decreasing, is going to decrease by 2 every time. That means it's going to be 30. And then this is going to keep going down, right? So it's going to be 28, and then 26, 24, and so on. But where does it stop? Like, does it stop at the end, or does it stop at the middle, or what? Okay, so here, let's see it when x is equal to 47, right? When x is equal to 47, then b can be from 48 to 51. No other values are possible, because 48 minus 47 has to be greater than or equal to 0, and 51 plus 47 has to be less than or equal to 99. So this gives us 2 values, right? That gives us 2 values. This gives us 2 values like that. And so this is the last one, right? Because if you look at any of the other values, let's try x equals 48. X equals 50, right? If x equals 50, then what will happen? B is going to be from 51 to, but then this value has already gone over 99, right? So b cannot be, so x cannot be 50. That means that 2 is our last value. That means we go all the way from 32 to 2, right? And so our final answer is going to be the sum of all the even numbers from 2 to 32, right? So 2 plus 4 plus all the way 2 plus 30 plus 32. This is just 2 times, and then 1 plus 2 plus all the way to 16, which is 2 times 16 times 17 over 2, right? So this is 16 times 17, which is equal to 272, right? So there we have it. 272 is our answer.